One day, the subways all stopped, the air conditioners shut down, and the lights went out for 50 million people. August 14th, 2003. It was the biggest blackout the U.S. had ever experienced.
The entire grid came down, just like a house of cards.
And we can expect more of these massive power failures.
The grid as it exists right now is very much like a very, very, very feeble old person.
The electricity flows typically for hundreds, sometimes or for thousands of miles through these frail aerial arteries. It's kind of miraculous it works at all.
But Bill Becker is hopeful and gets inspiration from his hero, Buckminster Fuller, a scientist and a visionary, best known for one of his creations, the geodesic dome.
Like Bucky Fuller used to say, there really is an energy crisis. There's a crisis in imagination.
He imagines a future with a much more efficient and reliable energy grid, one based on distributed power.
Distributed power is power that's generated locally, so it's power that's generated where it's being used.
Lots of little units are more reliable than a few big ones because they're unlikely all to fail at the same time.
Bill wants to see his city of Chicago with a distributed energy system of wind power.
Wind power is the cleanest of the energy sources, and it's the most readily available for us to take advantage of to move away from global warming gases.
He pictures a wind turbine on every building in the city.
A building can be a producing entity in terms of the common power grid.
There's a lot of wind energy out there.
Engineers and others will ask us, is there really enough wind in Chicago and cities? And there's a tremendous amount. There are 72 terawatts of usable wind energy in the world. The world only uses about 8 to 9 terawatts of energy.
But urban wind energy, capturing that is a whole different ballgame. Wind turbines are based on conventional windmills, invented many thousands of years ago. They work well out in the open, where wind flows steadily, turning a generator inside to make electricity. But in the concrete caverns of Chicago, the wind flows erratically around and over buildings. The whipping action of winds coming from different angles causes the long blades of a conventional wind turbine to flex and twist. It's dangerous and unstable in a city. At first, Bill tried a conventional turbine on his building.
It proved to be very difficult and actually scary at times, with ice throws, near runaways, and a lot of vibration and noise. So it taught me that the propeller was going to have a hard time functioning in Chicago.
So Bill looked for a safer way to tame the urban wind. His imagination took off one spring day while he was watching the movement of sailboats. He'd read about an inventor who'd made a spinning sail which ran a propeller. Bill's gears started turning.
I began building different kinds of machines.
We gotta get rid of one of these batteries because the torque transducer, this has to go, and we gotta use the universal joint.
After years of experimenting, he has a design that is his own creation.
They have a helical DNA-shaped center. We call it the helix.
He has combined the DNA shape in the center with a pair of airfoils on the outside. The result is a turbine that spins in the slightest breeze.
The S-rotor is an extremely good form for starting up the spinning of the turbine. The airfoils will give us a higher end speed to get the kind of power at the high-end winds that we also need.
It's not completely understood why, but while regular wind turbines can spin off their shafts at very high speeds, Bill's DNA turbines do not.
They never spin faster than 380 RPM. They never make a lot of noise because of that lack of overspin. They don't throw ice. They don't cause other kinds of concerns like centrifugal force spinning and throwing things away, like blades.
The slower speeds are safer for birds too. And while traditional wind turbines don't do well with turbulence, Bill's designs, with their large surface area, seem to thrive in it.
This machine, we found through testing, seems to enjoy or even like turbulent winds. When it's vertical, it can take winds from all directions at once. it spins in the axis of its support, so it's more like a gyro spinning. The faster it spins, the more stable it is, and it takes winds from all directions. Very important in the city because the winds will whip around and be multi-directional.
Thirteen of Becker's turbines are currently generating power in Chicago. One building is specially designed to capture urban wind.
Here we are at the Helmut Jahn designed building for Mercy Lakefront Housing in Chicago. We have 8 of our wind turbines on the roof of the building. The architect had a concept that the curved roof on the building could operate and help power the wind machines. So the building shape and the wind machine placement is reciprocal. It's not random.
The wind is converted into utility-grade electricity by a computer system.
This is a battery-free system. It's very high in efficiency, no noise, no vibration, and very, very safe.
When people call his urban wind turbines beautiful, Bill proudly recalls his idol, Buckminster Fuller.
Bucky said, if what you're designing doesn't turn out to be elegant or beautiful in some way, you're probably going down the wrong track.
Are they going to be hybrids?
You could add solar in at the end and it would be hybrid. You know?
Okay.
Growing demand for his urban wind turbines is affirming, too.
We have an evolving agreement in India to produce our machines there for 120,000 villages without really sustained power. We're developing a program in New York State and one in Italy. We're going to start one building at a time. We hope to see a revolution here really take off in the next 10 years.
Next, a bold experiment turns a contaminated shipyard into the most energy-efficient city in the world.